Hello, everyone. I hope you're doing all right today. Thanks for joining. So, at work recently, we've been having to make a lot of changes because we're scaling. And one major application that we built, we realized that the pipeline, it's gone so heavy and it's costing us resources and it is slow before we're able to do a rollout and a ship. So, we've been tasked to work on this pipeline. It's something that we've done more frequently, but this time around, I thought, why don't I make a video about it just to bring a an awareness of things that people could do, how to improve CI/CD pipeline. So, the way that I would handle this is I would answer it just as though I'm attending an interview, right? A DevOps interview, and say it makes you to be able to show your prowess about how to improve production based pipeline. It's a CI/CD pipeline. So and it makes you be able to express that you have worked in a production environment and you have the technical know-how because you've sat in the cockpit before. So the question goes to us: how would you optimize or speed up a CI/CD pipeline? Now, a weak answer is to start naming tools. Say, for instance, people might just start saying GitHub Actions, GitLab CI, excuse me, GitLab CI, Jenkins, Cycle CI, Argo CD. But those are just tools. So the strong answer is to show that you understand the pipeline as a system. You show that you understand every because we are system builders. All we do as DevOps engineers is to maintain systems, to troubleshoot, debug, make system better, improve financial obligation of our clients. So these are the works that we do. Now, um, the stronger answer is to show that you understand the system, right? And a CI/CD pipeline has different stages. It has dependencies, it has bottlenecks, it has safety gates, and if you optimize the wrong thing, you may just make the pipeline look faster while the delivery is less reliable. So my answer would be first, I would understand the application. It's very important to understand the application, what stack is it developed with, and all that. Then I will measure where the delay is. Then I will optimize the critical path without weakening the quality and security of the application. All right. So first, I will start by asking for context. I want to know because the application type, the pipeline purpose, and everything that makes this application. So I want to ask to understand the application, so I will be able to measure everything. Now, before I jump into optimization, I would ask a few follow up questions. Now, what kind of application are we building? Is it Node.js? Is it JavaScript? Is it written in Python? Is it containerized? Is it a microservice or is it a monorepo? These questions I have to understand them deeply. I don't just get into answering questions because the moment I do, it's very obvious that this person has not worked in a production environment, and you might just be a loose cannon for any company because you might just go straight into updating or optimizing what you weren't supposed to optimize. So I want to know what kind of pipeline we're talking about here. Is this for a pull request validation? Is it a staging deployment rather? Is it production release? Is it infrastructure changes? Is it a hot fix? Right? So we want to know these things, and then again, you want to ask what exactly is slow, right? You want to know: is it a dependency installation? Is it tests? Is it the Docker image builds? Are we talking about here? Are we talking about deployment rollout, or is it just waiting for an available runner? So these are different cases that we may want to know first before we are able to answer. Now, why does this matter? It does. It matters because the CI/CD pipeline for a Node.js front end may not look the same as Java backend, or whether it's a Python API. So, and the pipeline designed for fast pull request field feedback is not always the same as a pipeline designed for safe production deployment. So you want a faster pull request feedback, like really quickly, just to run through. Even if it's naming convention in the company, it's different from a safe, production deployment pipeline. So the first production minded answer is do not optimize by guessing. Do not go there and start to optimize anything. You want to optimize from the context that you have and all of the evidences that you have available, right? So, yeah. So the next thing is you want to find the real bottleneck. What are the real challenges here? Because the moment I understand the context, I would measure the pipeline. It will help me to be able to quantize, to be able to quantify rather. I want to know how long each stage takes. I want to know the checkout, the dependency install. I want to know about the linting. I want to know about the unit tests, the integration tests, the security scanning, the image build, the image push, and finally the deployment state. I want to know about all of these things. Now, a lot of teams, they usually say our pipeline is slow. Okay, but they have not really identified the real bottleneck here. If your pipeline is slow, okay, fine. But what part of the pipeline is really slow? How can we help? So sometimes it's the tests that are slow. Sometimes it's the Docker build that is slow because the Docker file, maybe it invalidates the cache too early. Sometimes we have varieties of cases. And sometimes the pipeline is just waiting in a queue because there are not enough runners, right? So sometimes flaky tests, they cause retries. And those retries, they actually are the things that waste time, that what wastes so much time. So before changing anything in the YAML file, before touching the CI/CD pipeline or your workflow, whatever you call it, you would want to check the timing data and identify the critical paths. I like to believe that everybody does this. So now the goal is not to optimize everything. The goal is to optimize the stage that controls the total feedback time. All right. We don't just want to jump into dating everything. So now the next stage, the next step, it will be to run independent jobs in parallel. Like you could do this. Now, the first practical optimization, the first thing that I'm going to do if I was in this situation is I want to run my parallelization. Now, some jobs don't need to run one after another. They don't need to run sequentially. They don't need to do needs this or whatever is important. But jobs can run independently of each other. Let's give, for example, if you are running LinkedIn tests, unit tests, and SAS scans, and some integration tests can often run, they can run at the same time. If the jobs are independent, there is no reason serializing them. Instead of doing links, then unit tests, then the security scan, then the integration test, you can fan them all out and have them run in parallel. Now, the total times becomes closer to the longest job, because you're still going to have a longest job along down the line. So the closest you're going to not the sum of all of the jobs. So, however, there is a trade-off here. Something just struck me now. There is a trade-off because parallelization only works safely when the jobs are actually independent. They have to be independent of each other. So if multiple jobs fight over the same database or the same test environment or the same runner capacity, you can create flaky pipelines or higher CI costs. You can cause that. So one thing that I would parallelize is independent jobs. And I would make sure that the test environments are isolated, or I increase the runner capacity to support it. So what do I mean in this case? Say I want to run different lanes, unit tests, integration tests, and whatever kind of test that I want to run. If I put them, so it's basically they should follow each other sequentially. This finishes running, the next one comes after, the next one comes after, which of course prolongs the time. But I could have about 3 or 4 jobs running parallel at the same time concurrently. Now, if I want to do this, that means I must make sure that they are running in isolated environment. My lint test is running in an isolated environment. My unit test is running in an isolated, in isolation, basically. And another thing that I will do in this case is I want to make sure that the runner has the capacity that can support it, because this normally a job that should just finish one, and once the first is done, the next comes forth. So this is like using a narrow bit of runners. The resources that you would need, you could run this. I don't want to give numbers now, but if you will run your job in parallel, then you would need more what's it called now, more runners to support it. So I want to run my jobs, I want to run them in isolation, I want to run in parallel, I want to give as much room for faster process. So now the next thing that I want to do is, the next thing that I am going to do in a case like this is, I want to have my what is it called, I want to run in cache, right? I want to have my dependency cached in CI. So the most pipelines that waste time downloading the same dependencies over and over again. You've downloaded pn package log.json. Okay, let me. So for Node.js application, say for instance, that could mean npm, it could mean pnpm, it could be yarn dependencies. If it's for Python, it could be PIP packages. For Java, it could be Maven or Gradule dependencies. It goes on and on, depending on if it's Golang, it goes on. So now, the right approach is to cache based on the log file. So for example, again, I'll talk about Node.js. It's very common. The cache should usually depend on the package log.json or the pnpm log.yaml or the yarn.log. So when the log file does not change, the pipeline can reuse the dependency cache because it's the same, because the application code, the log file did not change. Now, when the log file changes, the cache key will change and the pipeline installs fresh dependencies. And once these fresh dependencies are locked in, now it will continue to use the same cached dependency, right? So, but one correction that I would make here is GitHub Actions. In GitHub Actions, I would usually start with a built-in caching, like Actions cache, or set up node caching instead of immediately building my own S3 cache. Now, the reason is a custom S3 cache can work, of course, but the native CI cache is usually simpler and easier to maintain. It's already within not AWS. It's already within GitHub Actions, so I would natively use it rather than setting up my own, S3 cache system. So that is what I will do in my own case. I want to use a cache system which exponentially, dramatically improves how fast that the CI/CD pipeline that it works. So then I want to use Docker layer and build cache all together. Again, we initially talked about the application codes, layering and caching. Now we're talking about the build cache, because sometimes, or most of the time, the build step, the build stage and job takes one of the most time. There are so many things at work. We use something called golden images, but I may not want to talk about it in this video. Now, Docker builds are fast when layers can be reused. So they become slow when small code changes invalidate expensive layers too early. So I would write my Docker file very carefully. I want to write in such a way that it is well layered. It is well layered. My bad. That was the home routine. So yeah, in such a way that it is well layered. And let's say, for example, I want to copy the dependency file first. Then I will install the dependencies. Then I will copy the application source later, right? So that way, if only the application code changes, Docker does not reinstall every dependency from scratch. This is how to think production wise. This way, you're able to have your application code layers well cached instead of building, the full application base all from scratch. Now, for CI environments, one thing that I would do is I would use BuildKit or Docker BuildX so the build cache can be exported and reused between runs. Now, depending on the platform, this cache can live in the CI cache backend or container registry. So I would also reduce the Docker build context. So I will do that with a .docker ignore. Yeah, I'll add that in my IDE. So I'll add it to in my Docker ignore file. So there is no reason to send node modules, logs, test reports, build outputs, and secrets into the Docker build context. The Docker build is for the source code and the application and the dependencies, so they are well layered and built. And from a security standpoint, I would never bake secrets into Docker layers. So for private package tokens, I would use secret mounts or sorry, man, that cut. Okay, or use CI secret injection. I would use those properly. So those are the things I want to, the order that really matter. The use BuildX or Dockerx. So now I would run only what changed. Now the fourth optimization is conditional execution. This is especially very useful in a monorepo or a repository that contains multiple services. So, if only the front end changes, you may need to build and test the backend. If only the backend change, you may not need to rebuild the front end, right? I mean, it's a given. So now, if only Terraform changed, you may need an infrastructure workflow instead of a full application workflow. So basically, what I would use is path-based filters. I will use path-based filters inside of my CI for the affected service detection to be triggered to only trigger the relevant jobs. So this by all means reduces the wasted computes. It reduces wasted compute. It gives faster feedback. If anything fails, it makes the pipeline easier to understand. It makes it very, very, very easy to understand. And there is one important warning here. You do not want to skip jobs blindly. Please do not skip job blindly. So if a shared library changes, if a log file changes, or if a global config changes, multiple services are affected, or they may be affected. So your conditional rule must account for shared dependencies and not just the folder names. That is very, very, very important. Oh, this is not a disaster recovery topic. My bad. So yeah, you may want to pay attention to that and make requisite changes. Don't just skip. And now, lastly, if I would go through this one in an interview, so if I wanted to give it as an interview question, this is exactly how I would put it. So I would say, I would speed up a CI/CD pipeline by first measuring where time is actually spent. Then I would optimize the critical path. I would run independent jobs in parallel. Cache dependency is using reliable cache keys. Optimize Dockerfile layer ordering, and reuse Docker build caches across CI runs. I will use path-based conditionals, so unchanged parts of the repo do not rebuild unnecessarily. But I will not sacrifice quality for speed. Why? Because a fast pipeline that skips important tests, ignores security scans, or deploys unsafe changes is not a good pipeline. The goal is faster feedback with the same or better confidence. Now, this is a real DevOps answer. I will make delivery faster, but keep reliable, secure, and observable pipeline in place. So I hope this helps someone. I hope this makes a little bit of sense, and I hope that you like it. If you do, please do not hesitate to share, make some comments. Let me know if you want me to make any kind of video, particularly in any area or aspect of need. Thank you, and have a good one.